Okay, today we're going to talk about real numbers, the number line, and perfect squares and square roots. In mathematics, the term squared can often be written like this. It's written as an exponent, so it's raised up. It's really important that you don't write that, because that looks like 52. Your exponents need to be up, okay? It's important that we take the time to be neat. Otherwise, it's not readable to me. It's usually not readable to you at a later date. Okay. So 5 squared means 5 times, remember, we don't use x's for times anymore. We use this dot, or you can use parentheses. And we know that 5 times 5 is 25. Okay. So 5 squared is 25. 25 is called a perfect square because it is 5 squared. The reverse of squaring is called the square root. This little symbol here is called a radicand or a radical. And it stands for square root. We can have roots of other ones, but that's for the future. The square root of 25 is 5. So if any number is a perfect square, it means that it's a whole number squared is equal to that. So the whole number that equals 25 when squared is 5. So if you look at your note sheet, review number 1 says to circle the numbers that are perfect squares. I want you to pause this video and try to circle those. Okay? Okay, now that you've hopefully done number 1, I'm going to go through number 2. It kind of has this chart and it's side by side. My number is 1, my number squared. I'm going to represent number with x. X squared is 1. 2, 2 squared is 4. 3, 3 times 3 or 3 squared is 9. 4, 4 times 4 or 4 squared is 16. Okay. The numbers just count up 1 through 12. The two parts of the chart could be vertical. It's all one chart. They just ran out of paper. So I want you to, again, pause this video and go through and finish them. Remember, numbers just count 1 through 12. If you're not sure what, say, 9 times 9 is, go ahead and feel free to grab your calculator and get that answer is 81. So any of these numbers, if you don't know what they are when you multiply them by themselves, use a calculator and check that out. I would like you, within the next couple weeks, to get these numbers memorized. The perfect squares 1 through 12. So that's everything on the front page of our notes. The second page we're going to look at problem 1. It asks me, what is the simplest form of square root of 64? Well, what times itself? Well, we just did this in the chart and we saw that it was 8 times 8. If you're looking at number 3 there, it says simplifying square root expressions. What is the simplest form? Well, whenever I'm looking at a square root, I always have to have times itself. So this is my times. The simplified form of square root of 64. Actually, sorry, that's not quite right. Their little notes say 64 is 8 times 8. So the square root of 64 is what times itself equals 64. The square root is just the 8. I could also write my circled expression as 8 squared equals 64. Huh? We can do the same thing with fractions. And I know fractions can be a little scary. Actually, let's do another example. This one is not written in your notes. This is a perfect square. So if you noticed on the table, back on page 1 or labeled as 10 of your notes, we should have had 12. And we could see that the x squared column 12 squared was 144. Well, the next number here, 169, happens to be 13 squared. If I looked at it, this one, square root of 81, well, if I'm looking at my x squared column, I go find 81, and I see that that number is 9. 9 squared is 81, so the square root of 81 is 9. Oh, I keep writing squared here. Square root of 169 is 13. So this is perfect squares. Now, if I gave you something like problem 1, not sure who got this one, 289 is a perfect square. But I don't expect any of you to have that memorized. What you can do, however, is grab your calculator and check it. Now, everybody should have a calculator that has a square root button on it. Oftentimes it is second function of the x squared button. It's usually, square root is very often a second function. So it's written above your calculator and the second color, it's above the key. And if you press second function, so you'll press second square root, then you'll type in 289 and that should get you 17. If you need help with how to do that on your calculator, please pause and actually try that. But if you need help, please ask either your neighbor or Mr. Johnson, or whoever happens to be the paraprofessional if this is a different year. So that is square roots. We are now going to talk about putting some numbers in order on a number line. Okay? Or estimating based on perfect squares. And the example in the book is a little bit of a big number, so I'm going to do a little smaller one first. So we had our table of x and x squared. And 75 is between 64 and 81, meaning that this is between 8 and 9. I think it's a little closer to the 9 side, so I'm going to say 8.7 is going to be my approximate guess. If I want to get this exactly, I'm going to use a calculator. So if it says estimate, If it's within those first 12, I want you to make an approximate guess first and then check with your calculator. And the actual answer, a little bit rounded off, is 8.66. So 8.7 was a pretty good guess. If you come up with a guess somewhere between 8 and 9, if I said estimate, you estimate between 8 and 9, that's good. Because you're recognizing it is between 60, the 75 here is between 64 and 81. Okay. If it says to estimate one that's this big, I can tell you, and the book can tell you, that 19 squared is 361 and 20 squared is 400. But I don't expect you to have those memorized. Someday maybe we'll get the 400 memorized. And we could know that this is close. It's a little less than 400, so it's 19 point, I'm gonna guess 8. The book says it's approximately 20. Okay. They're willing to round that off. If you know the perfect square, that's great. If you don't, it's okay. Again, anything, I would accept anything between 19 and 20, but I need you to recognize that this is not more than 20. It's not 20.2 or something like that, because it is 386 is smaller than 4. Okay. So if you look at problem 2 on your notes sheet, it asks you, what is the value, integer value? So it wants an integer. Remember, integers are whole numbers or they're positive or they're negatives or 0. So what is the integer value closest to 34? Well, of the perfect squares, they gave you a number line. I'm just going to go say it. Look back at our table. 5 was 25, 6 was 36. That's pretty close to 6, so this is approximately 36. On the number line, they have 20. You could plot 5 squared here is 25, 30, 35. You're looking for this. You know that 6 squared is 36. Square root of 34 is going to be closest to 6, because square root of 36 it does equal 6. And they're kind of showing this with all the square roots. That's what the second line there under number 5 is. So it's closer to 6. Okay. Actually, we haven't talked about integers. That's what's about to come up. So we're going to talk about different sets of numbers. One of the things you're going to be asked to do is take a number, tell me what type of number it is. Okay. And I'm going to make this interesting diagram. They have it in your book on page 18, in which we're going to show different numbers. Okay. So inside here, we have the natural numbers. The natural numbers you have been using since you were a couple years old, probably even before preschool. Whenever you started learning to count, you started with natural numbers. 1, 2, 4, 17, 100. There's no end to the natural numbers. They start with ones. They count as whole numbers, which we'll talk about in a second. They're basically the same thing. The square root of 25 is a natural number because that's 5. Okay. You need to now know the term natural numbers. Whole numbers are all the natural numbers plus 0. Sometimes I don't know why we need a second set, although in higher math, sometimes it's nice to be able to say not including 0. So the whole numbers, every natural number is a whole number. That's why the natural numbers box is inside the whole numbers box. Okay? Because all the natural numbers are also whole numbers. I'm going to show you a little abbreviation. I'll put the abbreviations in red here in a second. Natural numbers, we'll use an N. We use a W for whole numbers. Integers is kind of weird. It's a Z. I'm crossing my Z so it doesn't accidentally look like a 2. I will do certain things with letters. Do that. The integers are all the whole numbers and their negatives. Okay. So now we've just introduced negative numbers. So when we talk about integers, we're talking about whole numbers or negative equivalents. Okay. So we can now have negatives. Again, the integers, all whole numbers are integers. So that's why this whole number box is contained within the integers box. Another example they have in the book is this. You got a fraction that reduces to a integer. We have the rational numbers. Rational comes from the word ratio. Ratio means fraction. So these are fractions. They could be negative. Decimals can be written as a fraction. All ending or repeating decimals, we'll make it so it repeats correctly, can be written as a fraction. You hopefully know that 1/3 equals 0.3 repeating. One-ninth is 0.1 repeating. So any repeating decimal terminating, or that's a decimal that ends, is a rational number. Okay, integers, like -10/5, are rational numbers. So far, any number we've talked about has been a rational number. The rational numbers, the abbreviation is a Q. Okay. Because we're going to use R later for something else. If there's rational numbers, there's also irrational numbers. And I'm not going to make this box quite as big, but it's not necessarily that there's a smaller set of numbers. I could go forever counting the natural numbers. So that's called, we say the set is infinitely large. The irrational numbers are numbers where the decimal doesn't repeat. The most famous one is pi, approximately 3.14159. You can look at the pi plate and see that that one I think goes to about 100 digits, but it goes on literally forever. Somebody's calculated it to like millions of decimal places. They're a bigger nerd than me. There's another one, E. Some other famous ones are square root of 2. These square roots that we're learning that you don't have are, if it's not a whole number for the most part, square roots are irrational numbers. Okay? That can be abbreviated with an I. And then finally, there's the real numbers. So irrational is this I. The real numbers, the abbreviation is this fancy R. Some people think it's kind of cool. I like it. It's a double-lined R. That is the abbreviation for real numbers. There are no real numbers that are not either rational or irrational. So if you look at 7 on page 2 of your note, got a little thing of natural numbers, 1, 2, 3, dot, dot, dot. Whole numbers, you just add 0, 1, 2, 3. You can fill in the gaps on the integers. I want you to pause for a second and cross out the couple of numbers that are not rational. 8. Okay, now that you've unpaused, you should have crossed out pi and square root of 5. Square root of 5 does not make a whole number. If you're not sure with a square root, you want to check it on your calculator. If you get a decimal, it's almost for sure irrational. Okay, classifying real numbers. Problem 3. So, the square root of 9 is equal to 3, so it is a whole number. Remember, anything that is a whole number here, let's do this for a second. If it's a whole number, it's also an integer, it's a rational number, and it's a real number. Oh, they don't ask for a real number. They ask for irrational number, and they put an X there because it's not. You cannot be a rational and an irrational number. It cannot be both. My second line, I have 3/10. 3/10 is a fraction that does not reduce to an integer. So it is not a whole number. It is not an integer. The first one, 3/10 is, I'm going to use the abbreviations here. Whole, integer, rational, irrational. Not a whole number, not an integer. It is a rational number. It's not irrational. Okay. I'm going to finish this up quickly. Hold on a second. I got it. Negative 0.45. That's not a whole number or an integer. It's got a decimal point there. But it's an ending decimal, so it is a rational number. Oops. Irrational was an X, not a check mark. We cannot be both rational and irrational. So that was my bad. The square root of 12. We're going to grab our calculator and we're going to make sure that that does not come out as a whole number. I get 3.4641, and that's the calculator rounding it off a little bit. So I'm going to say that this, it's a decimal that does not end. That is an irrational number. Irrational numbers are not whole numbers, integers, or rational. Okay? So number 10, concept summary, asks me to write each of the numbers in the box below. So I've got, oops, let's draw this differently. Got a box inside for integers. Got a box inside that for whole, and a box inside this for natural. And over here, I have irrational. So they give me the number -7. -7 is an integer, but is not a whole number. They need to be positive. Then the next number is -5.43. It is an ending decimal. Needs to go there. 0 is a whole number. It's not a natural number. 3/7 is a rational number. It's a fraction. Pi is irrational. And square root of 7 is also irrational. They had 5 filled in for the natural numbers. So they ask me to then write an inequality comparing these two. And I want to know which one is larger. So the big end of my inequality needs to go through that. So I'm going to grab my calculator, because I don't know the square root of 129. Square root of 129 is approximately, it's this little squiggly equal sign for approximately 11.36. So the 11.52 is larger. My inequality needs to go that way. Okay. So notice how they broke it down into step in 11. They broke it down and said, get the approximate value and then put the inequality symbol in. Okay, flipping over to problem 5. Let's put these in order on the number line. Well, the first thing they recommend doing is getting all of them into decimal numbers. So we've got 3.5, -2.1, those are already decimals. Square root of 9, -7/2, and square root of 5. So I'm going to put them under as their decimals, and you can use a calculator to do this. Square root of 9, hopefully you're getting down that that's 3. 7/2, as to put it into my calculator, I just do -7 divided by 2. If it's still giving you that as a fraction, ask for help on how to get your calculator to give it to you as a decimal. So now I got to put these in order. Okay? And to put these in order, I'm going to start with the most negative. My number line they've got here. I'm not going to label everyone. So here is -3.5. -2.1 is close to the -2, but a little bit smaller. Smaller means on the left. Or actually, this in the form it was given is -7.5. 2.23, square root of 5 there, square root of 9, and then 3.5 here. So now I've got them all on there and they're labeled. Okay. So if I want to list them in order from least to greatest, I just write them out. The number line is a very useful tool. It's important that you write them out in their original form. The number line, though, is a very useful tool for figuring this out. I asked you to identify the types of numbers these are in the lesson check. Well, I know that the square root of 100 is 10. Square root of 0.29, I use my calculator and I get, I'm using an approximately symbol because it is rounded off. And there's a bunch more digits. So this is a non-ending, non-repeating decimal. That's an irrational number. I is the abbreviation. Square root of 100 is 10. That was a natural number. Well, all natural numbers, if I look back at my box, are also whole numbers, integers, rational numbers, and real numbers. I guess it only specifically asked you to identify whether it's rational or irrational. Rational being Q. I know that's a little weird. But sometimes we're going to ask you to identify every type of number that it is. Okay? So then go ahead and check off the numbers that you understand in the math success. If you have questions about them, please ask a neighbor or the paraprofessional.